I'm going to teach you this concept called degrees of unsaturation. All right, this is a very useful equation. It gives you very useful information about the structure of an unknown compound, right? So say we are doing organic chem. There are some questions that they give you the molecular formula, but you don't know where to start. Okay, so using degrees unsaturation will help you, will give you actually more information about this compound, and it's really easy. It takes less than 10 seconds to actually get this information out. All right. Okay, so I'll always ask students to calculate the degrees of unsaturation. Is the very first task that I would recommend doing when you're supposed to find out the structure of an unknown compound. All right, so let's see what the formula is all about. Okay, so the degrees of unsaturation works this way. The number of carbon, all right, plus 1 minus half times the number of hydrogen. X is a halogen, and then N is a nitrogen. So once you plug it into this value, you get once you plug in all the numbers into this equation, you can calculate what they call the degree of unsaturation. And what does it tell us? It tells you the total number of double bonds and rings in the structure, right? But it doesn't tell you exactly. It does not tell you exactly how many double bonds there are or how many rings there are, but the total is the total number of double bonds and rings. Right, so let me just give you a rough idea, okay, how it works. Okay, so let's look at this formula, right? This is actually heptane, all right? Okay, so but before I say that, I just want you to take note. Okay, if you get a CC double bond, one CC double bond is counted as 1 degree of unsaturation. If you get a CC triple bond, is counted as 2 degrees of unsaturation. All right, so let's see what it means. So let's try. Okay, I'm gonna just move it here. All right, okay, let's look at this compound here. Okay, let's look at C6H12. Okay, let's look at C6H12. So if you use the formula, right, if you use the formula, I'm just going to probably do the first one and the last one. If you use the formula, the number of carbon, all right, which is actually, okay, let's do the formula. C plus 1 minus half H plus X minus N, all right? So number of carbon is 6 plus 1 minus half. Okay, there's no nitrogen and there's no halogen, is 12. So you work it out, actually this gives you 7 minus 6 actually gives you 1. So 1 actually tells you there's actually 1 double bond over here. It's okay? So let's try one more. Okay, let's try one more. Number of carbon, I'm going to use the formula. Okay, number of carbon, 6 plus 1 minus half. Number of hydrogen, which is 8. Okay, this gives you a value of 7 minus 4, that is 3. Can you see that? So you get 3 CC double bonds. So it tells you the number of double bonds. Alright, okay, last one. 6 plus 1, let's try this one. 6 plus 1 minus half 6, number of hydrogen. So 7 minus 3, which means it's actually 4. Okay, when you get 4, you can see that there's actually 1 degree of unsaturation here. 1, 2, right? And I want to mention a triple bond, right? Triple bond is counted as 2 degrees of unsaturation. So it's 1, 2, 3, 4. All right, so are you me? So 1, 2, 3, 4. All right, so because triple bond is a 2 degrees of saturation, so you get a value of 4. All right, okay, let's look at the next concept. Okay, let's look at the next concept. Okay, the next one is you can also count a hydrocarbon with a double C double bond O or C double bond N. So C double bond O is counted as 1 degree of unsaturation. C double bond is also counted as 1 degree of unsaturation. C triple bond N is counted as 2 degrees of unsaturation. So generally it's a double bond, right? Whether it's double bond O, C double bond O, or C double bond N, or C double bond C, actually is still considered as 1 degree of unsaturation. Okay, so let's look at some examples over here. So let me just do maybe 2 of them. All right, let's try this. Okay, if we use the formula, right, 6, okay, let's try using the formula. 6 plus 1 minus half. The number of carbon is 6. All right, the number of hydrogen is 11. Sorry, okay, the number of hydrogen is 11. Okay, so it's 11. All right, there's 1 nitrogen, right? So minus 1. So what does this give you? 7 minus 5 equals to 2. So really, if you can look at the structure, there are actually 2 double bonds. All right, let's try one more. Over here, number of carbon is 5 plus 1 minus half. Number of hydrogen will be 5. Number of nitrogen, there's 1, so minus 1. Okay, so the minus 1 is because of 1 nitrogen here. So this gives you 6 minus 2. So that gives you 4. Alright, it gives you 4. So is there 4 degrees of unsaturation? Let's check. 1, 2, 3, 4. Alright, so triple bond is counted as 2 degrees unsaturation. So you can see so far it works. Alright, okay, so let's look at the last concept over here. Let's look at the last concept. Okay, the last one. Okay, look at this part here. Each ring is counted as 1 degree of unsaturation. Notice, each ring is counted as 1 degree of unsaturation. Benzene ring is counted as 4 degrees unsaturation. Right, okay, so just remember that. Okay, let's look at some of the examples that we can see from here. Let me move it. Right, okay, so let's look at this one. Okay, if you use the formula, right, use the formula 6 plus 1 minus half, 12. Right, so this gives you 1. So you get 1 means there's 1 ring. Can you see there's a ring here? This cyclohexene, there's 1 ring. So let's try 1 more or 2 more. Okay, look at C6H8. 6 plus 1 minus half, 8. So this gives you 7 minus 4. That gives you 3. So why 3? Because you get 1, 2, and the ring. Okay, the ring is the 1 degree unsaturation, so it's actually 3. Okay, how about benzene ring? I think you can get the idea already. For benzene ring, number of carbon is 6 plus 1 minus half. Hydrogen is 6. So it gives you 7 minus 3 is 4. Can you see that? So why benzene ring is counted as 4? Because there's actually 1, 2, 3 double bonds and a ring. Okay, don't forget, and the ring. So that's why it's 4. Alright, so maybe just one more. Okay, let's look at this C10H16. So 10 plus 1 minus half, 16, right? So this gives you 11 minus 8. That gives you a value of 3. So let's see whether does it fit into the bill. Right, there's a double bond. Alright, and how many rings? 1 ring, 2 rings. So that's why you get a value of 3. Right, so this formula is quite useful. Basically, it tells you the number of rings and double bond. Right, it tells you the total number. It's I mentioned here, it's a sum. Alright, it's the word is the sum. It's the sum of the number of double bonds and ring, but it doesn't tell you how many double bonds or how many rings. Alright, okay, but it's definitely very useful. Right, it's definitely a very useful formula that you can use to solve elucidation questions. Okay, let's see how this is done. Okay, we're going to apply the degree of unsaturation formula to 4 real life examples. So let's look at caffeine. Right, does it work? Okay, this is the molecular formula of caffeine. So I'm just going to write the formula again. Alright, C plus 1 minus half H plus halogen minus N. Alright, so let's work at 8's carbon, hydrogen is 10, nitrogen is 4. Alright, so 9 minus 3 gives you, wow, the 6. Alright, so are there 6 degrees of unsaturation? Let's check. Alright, 1, 2, 3, 4. Alright, and I'll just want to circle this. 5, 6, 2 rings. Alright, so that's why you get 6. Okay, paracetamol. Alright, let's see paracetamol. Number of carbon is 8 plus 1 minus half. Hydrogen will be 9, nitrogen will be 1. Right, so this gives you 9 plus, not 9 plus, 9 minus 4. Okay, 9 minus 4. Right, so that gives you a value of 5. So let's see whether do we have 5 degrees unsaturation. 1, 2, 3, 4, and the last one is the ring, 5. Is okay? In fact, that's a benzene ring, so it's actually 4 plus 1. Okay, benzene ring is 4, this is 1. Okay, so that's why it's 5. Okay, let's try cocaine. Alright, let's look at cocaine. Okay, so it makes the formula 17. This is like a big number, right? 17 plus 1 minus half. The number of hydrogen is 21, nitrogen is 1. Okay, so this gives you 18 minus 10, so this gives you 8. Alright, so let's see whether there's 8 degrees of unsaturation. 1, 2, 3, 4, 5. 5, right? 6. Okay, 7. This is one ring. 7. 7. Alright, and the other ring is this 8. Okay, this is the other ring. Can you see that? There are actually two rings over here. So can you see 1, 2, 3, 4, 5, 5 double bonds and 3 rings, right? So that's why it's 8. Okay, let's try this last one. 2,4,5 trichlorophenoxy acetic acid. This is otherwise known as Agent Orange, used in the Vietnam War, right? A very, very potent chemical. All right, look at the formula. Okay, we're gonna just base on it and calculate. Okay, so okay, in fact, I got the wrong formula over here. In fact, it should be how many? In fact, it should just be C8, H5. All right, H5. How many oxygen? 3 oxygen. And how many Cl? There's actually 3 Cl. All right, so let's see whether it works into does it work here. So carbon actually is 8 plus 1 minus half. The number of hydrogen is actually 5. Okay, and there's halogen. Yeah, there are 3 halogen over here. Okay, so this works out to be 9 minus 4, so we get 5. Can you see that? So you notice why is it degree of unsaturation of 5? 1, 2, 3, 4, 5. All right, so it works. Okay, let's try this question from Temasek JC, all right, prelim 2009 paper. All right, okay, let's look at it. This compound A, all right, is oxidized with KMnO4 or manganese ions to form this compound and compound B, all right. Compound B produces CO2, all right, the effervescent CO2 when sodium carbonate is added to it and gives orange PPT with 2,4-DM pH. All right, so when it produces carbon dioxide with sodium carbonate, it says something about B. B is gonna be a carboxylic acid. Yeah, it's a carboxylic acid, and it reacts with 2,4-DM pH means it's also carbonyl. Right, so that's for B. Okay, compound A. Just draw. Compound A reacts readily with 4 moles of bromine. Okay, so what kind of compounds react with bromine? You must know it's either phenylamine, all right, or phenol, or even alkene. Okay, or even alkene. Okay, so we know that for phenol and phenylamine, you get 2, 4, 6 bromo compounds, right? So let's look at next part. Compound A also gives the orange PPT with 2,4-DM pH, right? And reacts with hot alkaline equals iodine. So the fact that A reacts with gives orange PPT with 2,4-DM pH, it shows that A is also carbonyl. All right, A is carbonyl, and actually the next part is A has an iodoform structure. Since it's carbonyl, I'm thinking that it should also have this CH3, C double bond O, and R group here. Okay, so it's a methyl ketone. Okay, so let's try. Okay, but one thing I have to tell you about the degree of unsaturation, it doesn't really apply to ionic compounds. So it doesn't really apply to this compound or this one here. Right? Why I say that? Because there's a charge over here. So I think this is probably a salt. Alright, so it doesn't really apply to formulas whereby it's a salt. Right? It's only for the normal organic compounds with no charges. Over here, this is also ionic compound. If you can see, there's an Na. So it's probably going to be something like this. So this is actually a salt. So you can't really apply the degree of unsaturation to salts, right? So but we can still apply it to A, all right? So that will give you a good idea what is present in A. So let's try degrees of unsaturation, all right? So let's look at the formula. C plus 1 minus half H plus halogen minus N. So the number of carbon is 10. 10 plus 1 minus half 11 hydrogen and 1 nitrogen. There's no halogen, but there's 1 nitrogen. So this gives you a value of 11 minus 5, that's 6. Okay, getting a value of 6, I'm thinking that it should probably be a benzene ring, all right, and 2 double bonds. So benzene is really 4, then probably another 2 double bonds. All right, so this gives you a rough idea what A should be. So A was broken up into 2 parts. One has 7 carbon and one has 3 carbon. Can you see? With KMnO4. So firstly, I'll draw a benzene ring, and in order to be oxidized that way to form 2 compounds with KMnO4, I think there should be a double bond somewhere. All right, I think there should be a double bond somewhere. 1, 2, 3, 4. Okay, so I drew 6 carbon. 6 plus 4, 10 carbon. Yeah. So I'm going to put a double bond here. Okay, why I say I put double bond here? Because I know that when I break this part here, you end up with 3 carbon. Can you see that? So this is where your 3 carbon is. Alright? Okay, you're going to take this away first. Alright? So this is what probably I'm trying to draw A. Yeah? Okay, another thing about A is they mentioned that it's a carbonyl. Alright, A is carbonyl and has this group here. So I'm going to just put it in. I think it should be over here. So it does now fit into the formula that it has a band 4 degree of saturation, 5 and 6. Alright, so that's why you can see that 6 degree of saturation. Now I'm going to put in the rest. Okay, but over here notice I saw a plus here. So when I see a plus, I'm thinking that this should be a salt. So why is it a salt? Because there's an acid. So an acid can have a base to form a salt. So the base is probably an amine group, which I'm going to write NH2 over here. Right, and if you look at it carefully, this looks like A. Alright, this looks like A because it fits in the formula of C10H11NO. Okay, you work it out, it will fit into this formula. Okay, but the only question I want to ask now is, how do you know that the 2 side chain is on carbon 1 and carbon 3? Alright, how do you know the 2 side chain? Couldn't the side chain be on carbon 1 and 2? So where I got my idea is from here. Compound A reacts readily with 4 moles of bromine. So because if we have so many moles of bromine, I'll definitely not put any side chain on the 2, 4 and 6. Okay, what I mean is this. Right? Just draw it out. So I'm thinking that the phenylamine will be here. Alright, phenylamine, I draw phenylamine. So the Br can actually go to the 2nd, 4th and the 6th position. So any other side chain on the benzene ring or phenylamine should be either on the 3rd or the 5th. So I'm going to draw a side chain here. So that's why you notice it's on the 3rd position. Right? So you allow the Br to go into 2, 4 and 6. Because eventually you need to have 4 Br. So that's quite a lot of Br. Okay, so but another thing you can take note of is because alkene can also react bromine. So this is probably something that you should probably get. So when you add bromine, you get Br and an OH because it's aqueous bromine. Alright. Okay, see whether does it fit into this formula. Okay, let's see whether it fits in this formula of C. Right, 10 carbon plus 1 minus half. Hydrogen, there's 9. Halogen, there's 4. There's 4 Br, so I must plus 4. Okay, nitrogen, there's 1 minus 1. So this gives you 11 minus 6. Alright, 11 minus 6, this gives you 5. So there's 5 degrees of unsaturation. So does it make sense? 4 plus 1 here, 5. Alright, so it does fit into this whole thing. Okay, so but I'm going to say this one last time. This formula doesn't apply for salt. So generally you can't apply the degree of saturation for something like this. But of course, if you want, you can actually do some adjustment. You can imagine you take away the Na plus and then you put in one H. Well, replace an Na with a H. Alright, and you think of it as like C9H9NO2. Okay, so reply the Na with a H and then you work it out. So if you work it out, it'll be like 9 plus 1 minus half. Okay, so this gives you a value of 10 minus 4, 6. Right, so there you probably know there's a benzene ring and 2 double bonds. Alright, for D. Right? Okay, so I hope this is quite useful and this is quite helpful. So always, if you're unsure, alright, you can actually start with what I call the degree of unsaturation. That will actually guide you in the solving of this kind of question. Right? See you another time.